Let's start the second part of this video where we solve few problems based on laminar flow in a circular pipe. So let's start. So this is your second problem. A crude oil of viscosity 0.9, that is dynamic viscosity 9.9 points. Specific gravity 0.9 is flowing through the horizontal circular pipe of diameter 120 mm and length 12 meter. Calculate the difference of pressure at the two ends of the pipe if a 785, it is wrong actually, it should be 785 Newton of oil is collected in a tank in 25 seconds. So this is the problem. At first we have to find out what are the given data. So here given data are dynamic viscosity mu, which is 0.9 is converted into 0.09 Newton second meter square. Then specific gravity is given of the oil, which is equal to 0.9. Then diameter of the pipe, that is D. Length of the pipe, L is given 12 meter, and weight of the oil, oil in 25 seconds is equal to 785 Newton. So in terms of Newton it is given. So let's start. So you know that Hagen Poiseuille equations, P1 P2 is equal to 32 mu average velocity L divided by D square. So here weight of the oil collected per second is given 785 in 25 seconds. So this is Newton per second. This is Newton per second, and which is equal to rho g cube. How it is? So for rho you can write kg meter cube. For g you can write meter second is 3 per square, and q meter cube per second. So this will go, and if you consider this kg and this g, so this is equal to mass. This is basically is your mass and g. So this is your Newton and this is your second. So this is correct. So from this you will get Q is equal to 785 divided by, this is rho G is 25, and this value is 31.4 Newton second. So your Q will be 31.4 divided by density, you know, 0.9 into 1000 into 9.9, and this will be 0.00355 meter cube per second. After that you have to find out average velocity. So average velocity U bar is equal to Q by area. So this is Q is equal to 0.00355 divided by pi by 4 d square. So U bar is equal to 0.00355 pi by 4. It will be 0.12 square. Which is equal to 0.314 meter per second. So let's see whether this flow is laminar or not. So Reynolds number U bar d by mu. So this is 0.9 into 1000 into 0.314 into diameter is 0.12 divided by 0.09. And if you solve the problem, you will get 376.8, which is less than 2000. So flow is laminar. So you have to find out the pressure drop. So here P1, P2 is equal to 32 mu this L by d square. So pressure drop, you have to find it out. 32 mu is equal to 0.9 to 1000. This is wrong, I'm sorry. This is equal to 32 into 0.09 into 0.314 into length is 12 divided by d square. D square is 0.12 square. And if you solve the problem, you will get 753.6 Newton meter square. So this is the solution. Thank you. To solve this problem, those are the given data: specific gravity 2.8, dynamic viscosity 0.8 poise to convert into Newton second per meter square, then pressure drop 800 Newton meter square, length of the pipe is 2 kilometers, so 2000 meter, and mass per second is 25 kg per hour. So convert into kg per second and divided by 3600. So you will get 0.6944 kg per second. After this we need the diameter of the pipe. Actually, for that purpose, at first we find out this mass flow rate is equal to rho A average velocity. Okay, rho is average velocity. So from this equation, you will get average velocity is given by mass divided by rho A. A is the area. Now if you put the value 0.6944 divided by, so rho is specific gravity into 1000 is the rho for the liquid, into pi by 4 d square. So d we don't know, you have to find it out, this diameter. And if you simplify a little bit, you will get 3.158 into 10 to the power minus 4 d square. Since it is a laminar flow, laminar flow, so P1 P2 is equal to 32 u bar L divided by d square. So P1 minus P2 is given, this is 800, 32.08, 3.158 into 10 to the power minus 4 into 2000 divided by d squared into d square. This d square for this one and d square for this one. And if you do the calculation here, d will be 0.2125 meter. Let's check whether this we are assumed that this is laminar flow. Whether it is laminar flow or not, we have to check. So let's check this. RS is equal to rho u bar d by mu. So 2.8 into 1000, this is the density. Velocity is 3.158 into 10 to the power 4, and this is d, and this is d square into 0.08. So d square will go, so ultimately it will be like this, 3.158 into 10 to the power minus 4, then 0.212, this is the diameter, 0.08, and here you will get 25, which is less than 2000. So it is a laminar flow. Thank you. Hope you understand the problem. So see you soon.